My name is Darren Carell. To start the video series on opioid pharmacology, we'll discuss what opioids are. Bottom line, is there any compound, either endogenous or exogenous, with activity at opioid receptors? To expand on this, we'll talk about where they come from, the basics of the receptors they bind, and briefly discuss specifics of the majority of the available agents. Any presentation about opioids worth its salt has to start with a picture of poppies. As with most plants, there are a number of different species, and the two of greatest importance to this topic are Bracteatum and Somniferum. Why they're important is that opium is the milky fluid that exudes from their seed pods when they're cut. Now, a trivia question. When was the first authenticated reference to the use of opium for pain relief? I'll give you a few seconds to come up with the answer. A century is good enough. So the answer is the 3rd century BC. This occurred in the writings of the Greek philosopher Theophrastus. Now, as many things in history, this claim is disputed. For instance, Sumerian clay tablets from the 4th century BC have ideograms that may reference medical, recreational, and religious uses of opium. So they lose because the writing still isn't fully understood, and thus it hasn't been 100% authenticated that the use of opium was for pain. Then there's arguably the most important medical papyrus of ancient Egypt, the Ebers Papyrus, from 1550 BC. It listed opium as an ingredient in a mixture for soothing children and for the treatment of breast abscesses. Here, the writing is pretty much fully understood, but it loses because the use of opium wasn't expressly for pain. Finally, we know that opium could have been used long before any of these references, because the earliest known evidence of somniferum seeds is from an archaeological site dating to the Neolithic period, about 5600 BC. But again, if it was used for pain is unknown at this time. Now let's move to the present day. Papaver bracteatum is a major source of the opiate alkaloid thebaine. Alkaloids are a class of naturally occurring organic compounds, meaning carbon-based, the black balls in the picture, and these mostly contain basic, or alkaline, nitrogen atoms, the blue ball. To be complete, the red balls are oxygen and the white are hydrogen. Commercially, thebaine is then converted into another alkaloid, codeine, and is also used to synthesize the agonists oxymorphone, oxycodone, and hydrocodone, the antagonists naloxone and naltrexone, and the mixed agonist-antagonists buprenorphine, nalbuphine, and butorphanol. Papaver somniferum also produces thebaine, but more so is the major source of another opiate alkaloid, morphine. Morphine is what is used to synthesize heroin. In addition, somniferum is where we get poppy seeds to make yummy pastries and bagels and such. Despite their being delicious, we won't be talking about this use. Morphine was the first individual alkaloid ever isolated, back in 1804. It was originally called morphium in honor of Morpheus, the dude from the Matrix. Not really. It was actually for the Greek god of dreams. Recall, opioid receptors are a group of inhibitory receptors located ubiquitously throughout the central and peripheral nervous system and other organs of the body. There are 4 types of opioid receptors, each with different endogenous ligands. The mu receptor has the endogenous ligands of endomorphin and endorphin. The kappa opioid receptor has the endogenous ligand of dynorphin. The delta opioid receptor has the endogenous ligand of enkephalin. The nociceptin receptor, with the abbreviation NOP standing for nociceptin opioid peptide, has the endogenous ligand of nociceptin orphanin FQ. The effects that occur when the opioid agonists bind these different receptors is discussed in another lecture in this series. Some texts list a sigma opioid receptor. It was once thought to be a type of opioid receptor, but then was shown to be activated by drugs completely unrelated to opioids, for instance PCP and haloperidol. When the receptor was cloned, it was found to have no structural similarity to opioid receptors at all. So we have to say goodbye to sigma. Now we'll briefly go through most of the clinically used opioid agonists. All the drugs on this list are full agonists at the mu receptor where they have high affinity. Most are also low affinity agonists at the delta and kappa receptors too, but the very, very minimal activity makes these actions mostly irrelevant. I'll point out those that differ significantly. The first agent that differs is morphine. In addition to most of its activity being at mu receptors, it is also a somewhat reasonable kappa and delta opioid receptor agonist. As the only medically used compounds naturally found in opium, morphine and codeine are the only ones properly classified as opiates. Diacetylmorphine, or heroin, hydrocodone, hydromorphone, oxycodone, and oxymorphone are synthesized from the various opium alkaloids and as such are considered semisynthetic. Loperamide is completely synthetic and has the unique property of only being active at mu receptors in the GI tract, and thus is used for diarrhea treatment by basically taking advantage of the common opioid side effect of constipation, which will be discussed more in other talks. Alfentanil, fentanyl, levorphanol, meperidine, methadone, remifentanil, and sufentanil are all 100% synthetically derived. Levorphanol, like everything else in this chart, is mostly a mu agonist, but unlike most, is also a somewhat reasonable agonist of the delta and kappa opioid receptor and potentially the nociceptin receptor, as well as being an NMDA receptor antagonist and a serotonin norepinephrine reuptake inhibitor. We'll discuss the significance of these last two in other video series. Meperidine may also be a kappa agonist in addition to mu, and methadone, in addition to being an opioid agonist, is also an NMDA receptor antagonist. This agent will be discussed at length in other videos. Then there's tramadol, also synthetic. It mostly has activity at mu receptors, and to a far lesser extent at delta and kappa receptors. In addition, it is also a serotonin norepinephrine reuptake inhibitor. Lastly, tapentadol, again synthetic, only binds the mu receptor and is also a norepinephrine reuptake inhibitor. And you guessed it, we'll discuss the significance of this in other presentations as well. The mixed agonist-antagonists have complicated and often not completely understood or agreed upon actions at the different opioid receptors. So what is mentioned here is a best effort at relaying what is known, but realize that it may be changed in the future as more research is done. Buprenorphine, as you'll likely imagine, will be discussed at length in other lectures, but its basic activity is as a partial agonist of mu, an antagonist of kappa, an antagonist of delta, and a weak partial agonist of nociceptin. Butorphanol is a partial agonist-antagonist at mu, a partial agonist at kappa, an agonist at delta with unknown activity at nociceptin. Now, bufene is an antagonist and possibly partial agonist at mu. It's a partial agonist at kappa, a very weak antagonist of delta with unknown activity at nociceptin. And pentazocine is a weak antagonist, partial agonist at mu, an agonist of kappa with unknown activity at delta and nociceptin. So, as you can see, quite complicated. And last but not least, the pure antagonists. They all have different degrees of binding affinity at the different opioid receptors. Naloxone has the highest affinity for mu, the next highest for delta, and lowest for kappa. It has little to no ability to bind nociceptin. Naltrexone also has high affinity for mu. Next most is for kappa and very, very little affinity for delta. Its affinity for nociceptin is not known. N-methylnaltrexone binds only mu receptors in the periphery, most importantly the GI tract, and thus it is used as a second-line agent for opioid-induced constipation. And the final agent to be mentioned is alvimipan, which most importantly binds mu receptors in the periphery, though also kappa and delta to a small degree. It is indicated to prevent postoperative ileus following partial, large, or small bowel resection with primary anastomoses. I hope you learned something from this talk. Please look for the other presentations in the opioid pharmacology series on the B-Corps website. And as always, thanks for watching.